And there we go. Over to you, Stefan.
Thank you. And I'm going to share my screen and start the presentation.
Yeah, we can see
there.
that presentation now.
Yeah.
Yeah, presentation mode. That's good. Thanks, Stefan.
Good. Thank you very much, Ivan, for the introduction. By the way, I'm based on Vancouver Island, so Western Canada. Hence, the time here is 5 o'clock. Yeah, so today I want to speak about SysON and give you a glimpse, a quick overview of what's cooking in terms of the next generation of modeling tool, and more specifically SysON, which is going to be an open source web-based SysML v2 graphical modeling environment. And so in this presentation, which is pretty much tool-oriented, I will be starting by introducing Obeo, who we are, what we do, and then I will switch to maybe a 10-15 minutes demo of the tool so that you can get a sense of the status of the tool and what we are developing. And then I will also spend some time speaking about our vision towards SysML v2 open source and why we are making this effort of developing SysON as an open source tool. And then I will switch to giving a little bit more information on the current status of the tool and the roadmap that we have for the months to come. Right, so let's start. Let me introduce quickly the company and more specifically where we stand in the MBSE landscape. So as Ivan introduced, I work for Obeo. We are a mid-sized software vendor. Our headquarters are based in France. I'm based in Canada, and we have some offices and people working for us in different parts of the world. And I would say that we have two main characteristics at Obeo. The first one is that we are specialized in developing modeling tools and modeling technologies. We've been doing that for the last 20 years. And the other aspect is we do a lot of what we do in the open source. We are active in mainly three different type of markets and tools. Our first activity is around building and providing domain-specific modeling environment for our customers. So basically, when customers don't find a standard or ready-to-use tool for tackling their business problem, we can help them to develop a domain-specific modeling tool. The second market is we are pretty active on the MBSE market with Capella and now SysON. And we are also pretty active on the enterprise architecture market with Obeo Smart EA, which implements the TOGAF, Archimate, and BPMN standards. So focusing more on systems engineering and MBSE, we are a pretty well-known organization for supporting and leading the Capella ecosystem. So Capella is an open source MBSE tool. We believe it's one of the top 3 most used system modeling tools on the market, depending on which country you are. We have more than 1,000 organizations using it. Some of you may be aware that Capella was developed by Thales, was created by Thales, and we are the second contributor to Capella, and we are actually leading the Capella open source ecosystem. So today, what I want to talk about is more what we are doing towards SysML v2. So at Obeo, we are an OMG member, and we've been participating to the SST team, so the SysML v2 submission team, since 2019. So not since the beginning of the SysML v2 standard, but quite close to the beginning. And we are also a member of the OMG system modeling community. So although we were pretty strongly focused on Capella, which is not a SysML tool, we've been looking at what was cooking on SysML v2 for quite some time. And as a software company, we've been doing some tooling development and prototyping over the years, either with some of our customers and partners or through internal investment. And up to a point where at the beginning of 2024, we started to develop an MVP for providing a web-based graphical environment for SysML v2. And that's is this effort that led us to the creation of SysON. So now for the context, I'm going to start introducing SysON. So what is SysON? SysON is it's a SysML v2 web-based authoring tool, and it's made available as open source. So one of the main focus of SysON is implementing the graphical syntax of the SysML v2 language. I will talk a little bit more about the specification later in the presentation, the SysML v2 specification. But yeah, SysON is really focused on providing an implementing the SysML v2 standards with a strong focus on the graphical specification. We are targeting to be standard compliant. We cannot claim that we are standard compliant for the moment because the standard is not validated yet, and SysON is not finished yet either. But really, we are working toward this goal of being compliant with the standard. In terms of supporting the graphical specification, we are going to also be supporting the API, the SysML v2 API, and we're going to provide interoperability with the textual syntax of SysML v2. And reason why we are not claiming to be compliant with the textual syntax is because we don't want to do everything, and there are other very good open tool initiatives to implement the SysML v2 textual syntax. So we are more going to be relying on those open source projects than redoing the work ourselves. So focus on the graphical syntax. It's a web-based tool, which means that it works on your browser, and it's open source, which means that you can access to the source code of the software, but most importantly, you can use it for free. So what I'm going to do now is I'm going to do a demo of SysON so that you can get a sense of what really SysON is and how it works and what's the user experience. So what I'm going to be showing tonight is a demo that you can do yourself if you are interested. So for that, what you need to do is you need to go to the SysON website. It's mbse-syson.org. You click on the Get Started button there, and you end up in the SysON documentation, and you've got how to install SysON basic local test setup, and that's going to guide you on what you need to do to install SysON locally and run it on your local machine. This is what I'm going to be showing you tonight. I'm running SysON on my local machine. This is not how you would deploy it in a production environment. It would be deployed on a server where several people could access it, but that's one easy way to evaluate and try SysON is to have it installed locally. And the installation is pretty simple. What you need to have is you need to have Docker installed. So you follow this link and you're going to be able to download and install Docker. And once you've done that, you just need to download the Docker compose file, which is a configuration file for Docker, and then run this Docker compose up command, and you should be good to go with running SysON. So that's the homepage of SysON when you start SysON and you access the SysON website. And what you can see in this window is you can create a new project. You can create a blank project, a SysML v2 project, a Batmobile project. The Batmobile project, we're going to create one. It's actually using an example models that has been created by Tim Wilkin and Christian Mugeo in a book they published under the Incusi UK, I think, which is titled Don't Panic SysML v2. It's a Don't Panic SysML v2 guide. And what you can do here as well is have a list of your existing projects that have been created on your SysON server. So let's start by creating this Batmobile example project. Right. So we can see that the window here is divided into 3 portions. On the left of the screen, we're going to have a view. We're going to see our model in a tree view format. In the center of the screen, this is our main view. Right now, we are looking at a diagram, which is a general view diagram. So for those who don't know, they've changed quite a bit the way diagrams are structured and named in SysML v2. And so the main diagram I would say that you're going to be using when working with SysML v2 is the general view. And then on the right of the screen, I'm going to move those video there. You're going to see some detailed information about the elements that you have selected. So what I'm going to do right now is I'm going to bring in on the diagrams all the existing elements that are in my model, and I'm going to rearrange them quickly. And here we have imported all the elements in one diagrams, all the elements that are available in my Batmobile example. So this is just a small example that comes from this book. So let's have a look a little bit about the user interface here. And the first thing that you may spot is that we don't have a tool palette, which is something that you would usually find in a diagramming tool. And so in SysON, the tool palette is actually contextual depending on where you click. So if I click on the background of my diagram, I'm going to be able to create a certain number of elements which corresponds to the most common elements that you would create in a general view diagram. If I click on another element, the options that I have on the tool palette are going to change because the context in where I'm clicking is different, and so I can create some other objects here which are different from what I was able to create. So we do have some tools here at the top of our diagram, and what I can do is, for example, I can toggle and start working in full screen mode if I want. I can zoom in, zoom out, but I'm actually using my mouse wheel, which is more convenient. And one interesting feature that I can show you is this one there. So I'm going to switch back to this mode. And there I can share my diagram with someone else. So when I click on this button there, I'm going to get this URL, and I can actually send it to someone else, and this someone else is going to be able to open it in a different browser. So right now I'm using Chrome. Let's say I'm switching to Firefox, for example, and I'm going to paste this link, and I'm going to share my screen in half with those 2 browsers. Right, and so the other person that you may have sent this link can actually open the diagram at the exact same place where the diagrams you were working on, and this person can start working on this diagram, and you're going to see that natively this is a web-based modeling tool, and so you're going to be able to see what others are doing on the models in real time. So it's pretty cool and powerful feature in terms of enabling live collaboration workflows when realizing modeling activities. Right, back to my demo. So you can export your diagram as an SVG file to share it as an image with someone if you want. You can toggle the green mode as well. We also have the helper line, which I can hide, so you don't see those lines anymore. But if I reactivate them again, it's going to help you to align your object with other objects. And we do have a bunch of other options that I won't detail today. Right, let's go back to the main screen and let's now create our own SysML v2 project, empty project, so that I can show you how you can conduct your modeling activities with SysON. So we have created this empty SysML v2 project. We just have a default package and then a default general view diagram that has been created here. So I'm going to start by creating a new part definition. And this part definition, I'm going to name it a car. And I'm going to say that the car is a subclassification of a vehicle. So I won't be explaining today exactly those concepts of part definitions, which are a little bit different to what the concepts that were present in SysML v1, but basically those parts are the equivalent of blocks in SysML v1. And so one thing we are trying to do with SysON while supporting the graphical syntax is also to mix it with the textual syntax. So basically, when I type that my car is a subclassification of the vehicle, which is some SysML v2 textual syntax, the tool was able to parse it and to detect that there is a link to this vehicle part definition. And as it didn't find any information about a vehicle in my model, it actually created it for us. So if I want, I can bring it in my diagram, and I can now see that there is a relationship between this part definition vehicle and my car. And now, if I create another part definition, let's say it's a bike, it's also of type vehicle, right? And obviously, I didn't type it correctly there. I made a mistake, but let's correct it. So now it's finding that the object is already existing in the model and linking it and making the right relationship directly with the right object in the model. Right. What I can do now is I can create an attribute on my part definition. And I'm going to name this attribute max weight. And it's going to be of type mass. And so when I do that, it hasn't created a mass element in my model here, because it has realized that mass is actually something that comes from the SysML v2 standard. So in SysML v2, the SysML v2 standard is defining some concepts like parts, part definitions, attributes, and so on, but it also comes with a very rich set of libraries that you can use. And so by default, we are hiding those libraries, but we can show them. So that's the SysML v2 libraries. There are also caramel libraries that I can show. I will talk a little bit more later what caramel is. But anyway, there are a lot of libraries that are already available for you to use in the SysML v2 language. And so if I click on my mass, which is typing my max weight, it's going to navigate to the library and show that mass is actually part of this ISQ-based SysML v2 standard libraries, which is also displayed there in this view. So let's hide those libraries. Yeah, so max weight is actually of type mass, and we are seeing what is called the full qualified name of mass, which is prefixed by the name of the library where it's stored, basically. Right, let's create some wheels on our car. So I'm going to create a new part, and there I can name it wheels. Say we've got 4 wheels for this car, and it's going to be of type wheels. And so we are also supporting this type of aggregation, which is part of the graphical syntax. And for those who are interested, we are also supporting the redefinition specialization, where, for example, I could create some bullet-proof wheels and saying that it's a redefinition of wheels. Right, and so that's a redefinition relationship that we've got here. So now what I can do is, for example, I can create a package, and I'm going to name my package bike parts, because this is where I want to store my bike parts, and then I'm going to be able to drag and drop my parts in my my bike part definition in my bike parts package. And when I do that, it's actually moved the element in the model structure automatically under the bike parts package. So we are, implementing this kind of behavior in the tool to make the life of the users that do those modeling activities basically easier. Some of the other nice features, for example, is I can decide to hide my package because I don't want to see it. Where is the hide? I lost it. Anyway, or I can decide to hide it here. I can decide to fade it if I want. And so when I fade an element, it's going to make it less visible in the diagrams, but it's still there. So it's another one nice features that we have. And then we can do things like doing some multi-selection of elements. And again, the tool palette is going to change. And here, for example, we have some nice features where you can decide to align the elements, arrange them, distribute them vertically or horizontally, etc. Okay, one other feature I wanted to show you tonight is a little bit in the same sense, where we are trying to provide some mixed user experience between the graphical and textual syntax. You can actually create elements using the textual syntax. So for example, if I click on my car object there and select a new object from text, I can type some text here, some SysML v2 textual syntax, and the tool is going to parse this text and create those objects for us in the model where I selected to create them from. So I'm just have this small file on the side that I'm going to use. I'm going to pass this text here, click create objects. And so now that I did that, I can bring in the diagrams those elements. So it's going to add automatically all the elements that are under the car, and I'm going to quickly rearrange all that. And we have created all these elements. We have a chassis, we have a body, we have a transmission system, we have an engine assembly with some parts, some cylinder set with a different cylinder of the motor. So all these elements were actually created by parsing this textual syntax, and I brought them then in automatically in the diagram. Finally, I'm going to show you a few other things. Right. So this is another example, which is a flashlight, which is one of the examples that they are using at the OMG for showing SysML2 examples. To show you some of the other views that we are working on. So beyond the general view, there is an action flow view in SysML2, which enables you to focus on modeling the action and action flow. So basically more the functional aspect of the functional modeling aspect of the model. We are also supporting the modeling of requirements. One interesting aspect with requirements is that in SysML2 you have some properties of your requirements which are named assume constraints and require constraints. So the assume constraints are constraints that you assume are going to be right for validating your requirements, and the require constraints are the constraints that needs to be met to be able to actually validate your requirements. And my point here is that those expressions like flashlight.actual weight less than 250 milligrams, it's not just text, like this text in the documentation, the actual weight should be less than 0.25 kilogram is text. This is not text. This is actually a set of model elements that are parsed and that have a strong meaning in the model. And for example, this kilogram actually reference the definition of what a kilogram is in the SysML2 libraries that define weights. Right. We are also supporting use case modeling right there. And we also have another diagram, which is the interconnection view. So the interconnection view is very close to what would be in SysML1, the IBDs, where you're going to be able to define the ports and interfaces between your subparts. And finally, we have also started to develop the state view, which is used in SysML2 for modeling states. All right, that's it for the demo. And let me go back to the presentation. So what I want to talk about now that you've seen what we are doing with SysON is I want to talk about what is our vision for SysON and what is our vision with SysML2 at Obeo. And so by that, I want to explain, why we are doing that as open source, why we are doing that as a web-based tool, and why we think this is very important to enable the success of SysML2. And so what I like to start talking about is giving a little bit of context about the status and the adoption of MBSE across the industry. And I like to share this diagram from that is extracted from the 2020 SERC MBSE maturity survey. This is a diagram. This is the main diagram that is presented in the summary of this survey. It's a pretty extensive survey. I think it's more than 250 pages, the whole document. And it's basically the overall capability maturity scorecard. And what you can basically see is that it doesn't look great, and even the capabilities that are in green there are trust that the environment is secure and trust that the environment protects IP. So not the main characteristics or the main outcome that you would expect from deploying MBSE on a project or in an organization. And then if you look at things like technical management, models are the basis for technical processes, MBSE is the basis for technical reviews. Well, that's not a great result when you look at the maturity in the industry. So my point is that there need to be some significant change in the way we are doing MBSE so that it's the adoption and the maturity becomes much higher in our industry and in our systems engineering practices. And I'm just sharing this webinar that was organized by in COSI in October, where the title was Accelerating MBS Adoption, Can SysML v2 be the game changer? So, this is really what we are talking about here. We are really in a situation where we need a game changer to improve our transition towards digital engineering and to enable us to be better at coping the complexity that we face in our systems engineering projects. So this is basically why SysML v2 has been created. SysML v2 has been created for overcoming some of the main challenges that have been encountered for using SysML v1. And those main challenges, I believe, are those three. First, main challenges are around interoperability and integration of tools. We are probably all aware that exchanging model between SysML tools is really a challenge nowadays. But it goes beyond exchanging models between SysML v2 tools. The really integration challenge is between system modeling tools and the other tools, all the other tools that you are using as system engineers, whether it's upstream tools like requirements management tools or downstream engineering tools, analysis tools, simulation tools, etc. And then there is really a challenge in the integration between all those tools, and SysML v2 is trying to address that. What SysML v2 is trying to address as well is much better extensibility and expressiveness. And this is the reason why SysML v2 is trying to address those challenges, is to enable actually better integration between tools, because for having good integration between tools from different domains, you need both an excellent expressiveness, but also the ability to extend the language to support the specificities of the other domains. And the third point, which is the usability and the adoption barriers. Using SysML v1 is not easy. So again, the extensibility and the expressiveness is hopefully going to help into helping with those challenges. So let's look a little bit about what is happening with SysML v2 and SysML in general. So SysML v1 was released first in 2007. It has evolved since. I think SysML v1 was released around 2010, and this is where the first industrial usage of the actual SysML v1 language happened. And SysML v2 development started in 2015, and so between 2015 and 2017 was developed the SysML v2 RFP, so the request for proposal. And the first work that was done was listing and studying the main challenge from SysML v1 that needed to be addressed with SysML v2. So if you're looking for understanding what are the challenges with SysML v1 and the limitation of the SysML language, well, this has been very well documented and published since the end of 2017. And so the actual development of the language started in 2018. The beta 1 of SysML v2 was released a couple of years ago, and now we are in the finalization of the language. The adoption of the specification will happen toward the middle of this year. And that's for sure. I'm not sure it's going to be May or June. I think it's going to be June. But the adoption has been delayed over the last couple of years, but there is no way to delay it anymore. So it's going to be out mid of June this year. So what is this SysML v2 specification? Well, it's a set of PDF documents. The first document is the kernel modeling language. You will hear about it as KML. And what it means is that SysML v1 was actually based on UML. That's not the case for SysML v2 anymore. The specification team has designed a whole new foundational language, KML, which defines things like classes have attributes, they have relationships. So it's very high level elements that are defined in the kernel modeling language. The second document is the SysML specification itself. The first in two parts, first part being the language specification and the second part, the SysML v1 to SysML v2 transformation. So I want to draw your attention to that. There is a specification that explains how you're going to be transitioning from SysML v1 to SysML v2, in a sense, transforming a model from v1 to v2. You have to be very careful with that. And there is a DoD working group that is working on this topic of transformation. Because when you do an automatic transformation like that, you're going to end up with some SysML v1 concepts expressed in the SysML v2 language. But SysML v2 is just not about renaming some concepts like we don't have blocks anymore, we have part definition. That's not about that. SysML v2 comes with some new way of modeling. And so beyond the automatic transformation that you can do, if you really want to take advantage of SysML v2, you're going to have to ask yourself, okay, how would I have modeled that in v2 if I had the v2 capabilities? And if you really want to take advantage of v2. And finally, there is a system modeling API, and that part is going to be very interesting and very useful for interoperability between tools. So it's basically defining an application programming interface on how you can connect, get and update SysML v2 models or elements as in a standard way. The specification team is also delivering a couple of other elements. They are delivering a presentation on the SysML v2 notations. They are delivering a pilot implementation, some model examples, and some standard libraries. And that's another big part of SysML v2. As I said in the demo, it comes with a very rich set of libraries that you can reuse in your models. And we are talking about more than 1,500 pages. So the SysML v2 specification is not small. The scope of SysML v2 is actually larger than SysML v1. And if you imagine that SysML v2 is going to be easier than SysML v1, well, that's not the case. It's not easy. SysML v2 is not easy. I mean, there are definitely things that have been improved and that makes it easier to learn. But I wouldn't qualify it as a simple language. I'm going to go through another couple of evolutions. It's definitely not exhaustive, but one of them is that SysML v2 comes with a textual and a graphical notation, as I showed you in the demo. So that's going to change quite a lot of things, as well as you can use the language using text. And another very important evolution of SysML v2 is that it enables now usage-focused modeling. So basically, in SysML v1, you cannot do almost anything if you are not defining definitions, if you are not defining types. And this definition and types ideas come from the software language, and so it's not often natural for system engineers to start thinking in terms of have to create an abstract type of a car. I mean, I'm not developing an abstract car, I'm developing a car, right? So why do I need to define an abstract type? Well, in SysML v2, you can directly work with those instances. I'm modeling a car with a wheel without having to define those definitions. Still, you can continue to work with define-oriented approach as well, and an actual mix of both is a really interesting approach when modeling with SysML v2. So now back to changing the game with SysML v2 and where we are with MBSE. What you have to keep in mind is that SysML v2 as a standard, it's exciting, it's a new language, it's going to have some new capability, but it's just a language, right? And I'm not saying that in a bad sense, but I'm saying that in the sense that if you want to use MBSE, you need a language for sure, but you also need a method, the method being, okay, how you're going to use the language, for what purposes, what's the best way to use the language so that it's going to help me in that context for that project. That's really something which is needed when you want to do some MBSE. And the other part is you need tools, because again, the SysML v2 specification is just a specification. And as long as you don't have tools that implement the specification properly, it's not going to be much useful to you. So that's where we enter into play, and I made a presentation at the last INCOSE Western State Regional Conference about that, which is why we think that for MBSE to be successful and for SysML v2 to be successful, it's really important that tools like SysON emerge and provide those services to the community. And for SysML v2 to be successful, what we need is we need to have accessible tools. We need system engineers who are used to use Excel, PowerPoints, and so on. They need to, if we're going to say that everybody is switching to digital engineering and is switching to MBSE, it needs that those tools, they need to be as easily accessible as Excel or Word or PowerPoint, right? We need to prevent vendor lock-in. We need to make this data accessible. Because if we are spending time entering models, those data needs to be easily accessible to other stakeholders, to other tools as well, to analyze them, to AI and so on. We need to provide also modern user experience. We are having a new generation coming on the market, and training the workforce is a challenge as well. So, they're all used working with their phones. So we need those modern experience in the modeling tools. We need to enable the development of libraries, and it's a really important aspect that I haven't touched too much tonight, but libraries is a new mechanism for SysML v2 for extending the language. And if you want to tackle the usability and accessibility of the system modeling language, libraries are going to be playing a very important role, like, for example, libraries of ontologies. So you're working in the space domain, you're going to be wanting to have a space ontology on top of your SysML v2 standard, and that's where libraries are going to be playing a key role. And obviously, if everybody is developing its own space library, well, those models they're not going to be interoperable, and the readers of those models are not going to be able to understand those models. And we need to have competitive price as well for accessibility. And so that's why we have decided at Obeo to develop SysON as an open source, web-based and state-of-the-art modeling tool. And we believe that SysON is going to be playing a key role by providing the SysML v2 foundational capabilities accessible to most of us and at a very low cost. So there are a lot of benefits with open source, and open source is actually mainstream. Most of us are using open source software or are using commercial software that are built on top of open source software. And what I'm saying with that is not that everything should be open source and that there shouldn't be any commercial software. What we are seeing at Obeo is that those foundational capabilities, which are implementing the standard, enabling users to visualize a model, visualize the diagrams, enabling a user to create a part definition. That's not where the value of SysML v2 is going to be. And so that's not where the competition should happen. Those foundational capabilities, they should be available to most of it as open source. And this is what we are trying to do with SysON. And by doing that, it's going to also lower the price expectation for those foundational capabilities in the commercial vendor tools. Right, a few words about our status and roadmap of SysON. So we are leading the SysON project. We are co-leading the SysON project with the French Atomic Energy Authority called CA-LIST. I've put here a couple of a few of the initial interested parties. There are much more organizations that are collaborating with us now to make SysON, to evolve and to improve SysON and to make it a success. And this is an overview of the features that we are supporting right now with the tool. My point is that we started the development of SysON just a little bit more than a year ago. So it's still a young tool. We still have work to do, but we are making great progress. We are supporting most of the views that are defined in SysML v2. We don't have the sequence view yet, but it's going to come in the next months. We don't have everything in terms of diagram management, but it's making progress. For example, the undo redo is going to be released next month. And yeah, it's making actually great progress. I can talk a little bit about the architecture and the technological choice that we've made on SysON. But the point is that we are relying on very mainstream and up-to-date web technologies. In theory, if you want to use SysON, you will have to deploy it on a server, or we are going to offer solutions where we're going to deploy it in the cloud environment as well, but you may deploy it in your premises as well. And what you're going to need is a browser to use it. So we are currently supporting Chrome and Firefox. Maybe one interesting aspect about SysON is that we are actually developing SysON on top of another open source component called SiriusWeb. And SiriusWeb is a low-code modeling platform. And why this is important is that we believe that because of the extensibility mechanism of SysML v2 and the libraries that I mentioned before, it's going to be very critical for any SysML v2 modeling tool to provide some very powerful capabilities for extending and specializing the tool for those libraries. And because we are building SysON on top of this low-code modeling platform, SiriusWeb, it's actually very easy to extend the tool, customize it for your own library, your own methodology, your own concepts. So that's something that we're going to be able to demonstrate in the next couple of months, and that's going to be a differentiator factor for SysON as well. A couple of words about Capella. So one of the reasons why we are developing SysON at Obeo as well is because we want to make sure that all our Capella community are going to be able to benefit from what's coming with SysML v2. And so we are studying different technical scenarios for that. First option that we are discussing is to implement a future version of Capella that would be implemented as a library on top of SysML v2 and so on top of SysON, which would be pretty cool. We have also worked with some partners, and some partners also have the capability to exchange, import and export SysML v2 models, Capella models back and forth with SysML v2. So that's also already something that you can do. And there are other technical scenarios that we are evaluating as well for providing interoperabilities between the Capella world and what's coming with the SysML v2. So in 2025, what we are aiming by the middle of this year is to reach a first level of maturity where SysON is going to be close enough to the standard that it can be used for teaching and for experimenting and conducting some pilot projects in industrial context. So that's really what we are working on right now. We have a lot of collaborations with different stakeholders who are involved in the adoption of the SysML v2 standard and who are helping us to make sure that SysON is going to reach this maturity in the next few months. And by the way, we are releasing a new version of SysON every 8 weeks. So if you are interested to get involved, don't hesitate to contact us. We have an early adopter programs where we can give you access to SysON that is deployed on a cloud environment, and we can have discussions about things that you think we should improve in SysON. So that's a very efficient way for you to influence our roadmap. And we are also starting some more industrial open collaboration where we are working with, I would say, early adopters of the technology who want to use it on real projects. And we already have a few projects which have started with some large industrials like the European Space Agency who are going to be using SysON in some very large projects very soon. So we are very interested also in this type of collaboration where we can make sure that SysON fits what's needed for those industrial projects, but also, get some help from these large organizations who wants to who understand that a project like SysON is going to be very important for making sure that SysML v2 becomes a success and that we can all enter into the digital engineering era, basically. And with that, that was quite a lot of information, but I'm happy to take some questions.
Oh, thank you, Stefan. That was very good. Exciting times. It's taken a while to get here, though. I hadn't realized the length of development and discussion around getting to this point with SysML 2.
Yeah, almost 10 years, right? Actually, a little bit more.
Yeah. So we do have some really good questions. I would normally read through them, but they're quite wordy. So I'll first, I'm just going to go to Armin. You have your hand raised, and then I'm going to go to some of the questions in the chat. Go ahead quickly, Armin.
Thank you, Stefan. Very good presentation. So first question is about the methodology. Is there any embedded methodology with SysON, like the Arcadia with Capella?
So no, there is no embedded methodology with SysON. The aim of SysON is providing a state-of-the-art implementation of the graphical syntax and the API as well. And then anyone can bring in their methodology. We are discussing with some of our partners to, for example, bring Arcadia on top of SysON. But that would probably not be hosted into the SysON project, open source project itself, right?
Great. Thank you.
Okay, thanks, Armin. Next, we'll go to Rob Corcoran. You've had a lot of good content that you expressed in the chat. As I say, rather than read it, I think I'll just turn it over to you. If you're, please feel free to unmute your mic.
All right, thanks. Yeah, great discussion. I think it's opening a lot of doors. I won't go through all of my questions. There's certainly a few words in there, as you've noted. I guess from a software perspective, when we've used SysML, flowing it down from customer requirements down through system requirements, subsystem requirements, and then allocated and broken it out. Eventually, you get to your software. You can be doing some VHDL work as well, and in some cases, your design could be representing hardware. Haven't seen it used as much there, but there's certainly opportunities for that. The SysML1 marriage with UML allowed us to take, and it allowed the tool vendors to provide an environment where the traditional UML world, which was not suited for systems engineering, hence SysML's arrival, but you could marry it with your design layers with UML, right? You could have design entities which tied back to the requirements, which were coupled to the objects capturing behavior in the model. So you had those links. One challenge with kernel modeling, like KernML, is that decoupling from UML. It certainly adds a dimension, as Stefan showed us, but we've also then lost that direct bridge. Are there any intended strategies to perhaps provide a means of tying it through, through some standardized approach to allow information to be conveyed to UML tools, or is it something for teams to develop on their own with whatever scripting they have?
Yeah, I think that's I'm not sure exactly what's going to happen. I would say that I wouldn't be surprised that some of the UML tool vendors develop some transformation where they can take some SysML models and transform them into UML. Maybe UML 3 or 4, I don't know, will be based on KernML as well. That may be another.
I would simplify it.
Yeah, but I would say that there are a lot of other tools out there before talking about reusing some content for doing some UML modeling for software. And the expectation there is that with the API, a lot of these tools are going to be developing those standard connectors. So if you want to take a SysML models and put it in MATLAB Simulink, there's a good chance that MATLAB Simulink is going to develop a SysML v2 API connector within MATLAB, which is going to be a standard way for sending data in MATLAB. And a lot of the analysis and simulation tools, it is expected that they will do that as SysML v2 becomes really the standard for kind of being at the center of the digital engineering ecosystem. And that's what's going to really ease the interoperability between the tools.
Okay. There's no chance that a parallel approach could happen if you have, say, a UML vendor who's moving and adding kernel modeling language. The concepts, the models themselves still represent quantities which are captured on the SysML1 realm. Is there any way that they could coexist? So you have kernel modeling language and the representation there for generating and updating, but then also a parallel representation on the UML side, right, on the SysML1 side, right? Because these are similar. It's just your entry points are different as far as using kernel modeling language.
So I'm probably not an expert enough to answer this question, but what I have seen from the discussion in the SSC team is that the core members and someone like Ed side of it, they are very well aware of what's in UML and why it was like that in UML and why it was like that in SysML v1. And so they were very careful in the way they have designed KernML and SysML v2 so that those things are going to be compatible. What's going to be the effort? Who's going to do it? I don't know. But there's a good chance that you're going to have those equivalencies that technically could exist.
Nice. I think it makes sense for the vendors if they want to support the path down through design, right? And if they have round trip engineering from their designs. So that would be certainly a logical consideration.
Yeah.
Excellent. Thank you.
But and to me, when you do that, you're going to need to add some methodological aspect, because which part of the model corresponds to your software, which parts you want to transition, etc. So it requires some organization in your model, and then some taking into account some of the approach you are using.
Exactly. That's certainly a challenge for the vendors, but they've been around for decades, the key players,
Yeah.
and so it should be in their wheelhouse.
Oh,
Thank you, Steve.
thank you, Rob. That was good input, good questions. Yeah, next we'll move on to Steve.
First, I just want to take the opportunity to welcome you as our 51st state, although we have to be honest, it's kind of a race between you and Greenland, but either way. 51st. Two quick questions. One is, what are you doing about executability and animation? And second, what is your vision for integrating all this with LLMs? Because we obviously want to chat with models, and we want a natural language interface to the model.
Right. So executability, we on Obeo side are not doing any work at the moment. We are following some of the work that is being done by the OMG on that. I'm going to say two things. First of all, our partner, the French Atomic Energy Authority, is really focused on the executability aspect, so they are starting to work on this topic for SysON. The other aspect to it is, and something I didn't mention in the presentation, is that a lot of the work that has been done with SysML v2 and Caramel is to make it based on a formal foundation. And outside of it, with one of the two SysML v2 leaders is specialized in executable models and executable UML, and is coming from this world. So that's a strong focus of the SysML v2 language is its executability. Large language models. Yeah, one way I can answer your question, which is I'm not sure exactly how. I mean, that was a pretty broad question. From a technical standpoint, integrating a technology like SysON and a large language models is pretty easy. We've done it. We have demos of that. We're going to be showing that in the next month. And there are two ways of doing that. Either you can use large language models to generate SysML v2 text using the textual syntax, which could be seen as a natural way of doing it. When it comes to SysON, we've done it by giving to the AI the API of SysON on how it can manipulate model. And it's actually pretty efficient because it's relying on the tools to make sure that all the elements required are created correctly. But we are also giving the API, we are also giving the AI the result of its execution, so that when things are not executed properly or created properly, it's going to actually correct itself and make the right API calls. So the bottom line being that from a technical standpoint, it's not very difficult to couple large language models with this type of technology. The next question, and you can use it in a lot of different use cases. I mean, obviously the most obvious one would be, okay, let's bring in the AI to help me to create my model and help me think about my model. I think it would have its limits based on what the AI has been trained for. But there's a lot of things that the AI can be also useful, like you give this model to someone who doesn't know anything about SysML and wants to get some information, and the AI is going to be able to request the model and give you answers. And things like that were difficult to do, like, okay, I want to rename automatically all my model element of these types with this pattern of naming it, which sometimes requires to learn a query language and so on. Same thing, you're going to ask the AI, okay, can you rename all these functions, blah, 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 and it's going to do it for you. So it's going to be very, very interesting in how it's going to ease the way to work with modeling tools like that. Now we've been experimenting the other aspect to it, which is, validating your models, helping you to find gaps in your models and helping you create elements with models. And that's a little bit more tricky. It's not always that easy to make the AI understand the different level of abstractions that you have, and that you are going to lower level abstractions, and two lowers down the lane, it's starting to give you some ideas that are two layer upper in terms of abstraction. It's also very difficult to give to the AI the whole context of your model. So yeah, there are going to be some challenges in how the AI can actually help you to think about the whole model, I think.
Thank you, Steve.
Thank you.
Let's see, last individual in the chat is Daniel. Could you please unmute and ask your questions?
Yeah, sure thing. Thank you. First question was that you showed the ability for one user to be editing and for another user to see the change happen. What happens if two users are making simultaneous but incompatible changes? How do you resolve that? And the other question I had to do with, do you believe, or in your roadmap, do you have the capability of generating views based on the model content instead of just manually creating them?
Yeah. So first question. So I'm going to give you two answers on what happens if someone, you give access to the same, let's say, same diagram. It could be different diagrams, but looking at the same elements in the model, what happens if someone does a concurrent change? So on the open source version of SysON, it's going to be the last one who did the last change got his change in, right? So it's not very intelligent in the way it's handling these kind of changes. And by the way, when you use SysON as an open source version like that, it's not authentified as well, so you don't know who's doing what, right? What we're going to be providing is an enterprise version where, for example, we are enabling some authentication capabilities so that you can know who is doing what. Then you can define, rights as well, who has the right to do what. And then we have the ability also to develop some capabilities where we can detect that you are trying to change something that someone already made a change in between. We have the exact same capability for Capella in our commercial tool called Team for Capella, where we enable live concurrent modeling like that. And so we're going to be implementing the same kind of mechanism where we make sure that if someone does something, change something on an element that you're editing, you're going to be preventing from doing it. So that's for the first question. Second question, generating view. Yeah, so there is already a way to do that within the tool, but it's not yet documented. But the answer is yes, we are going to be able. You're going to be able to generate views with SysON. Right now, you could do that through an API. The target is probably also going to be using the concepts of views and viewpoints. And those concepts are actually defined in the SysML2 specification. So the SysML2 specification defines concepts for views and viewpoints, where you're going to be able to say, I want to create this view, and in this view, I want to see these elements, but I don't want to see those elements, blah, blah, blah. So the target would be that you could actually define what you're going to see in those views in SysML v2 as well, and that SysON is going to be able to generate those views for you.
Good. That'll be handy for organizations that want to customize to meet their processes and best practices.
And we are working with some of the SysML v2 teams on that aspect, because in the SysML v2 specification, they have images for defining what's going to be the graphical representation. And so when they did that, there was no SysML v2 tool. So they used Draw2D to draw those images, but there's quite a lot of them. And now what they want to do is they are envisioning using a tool like SysON to generate automatically those images based on the text that they have. So typically a use case where you would have to generate those views automatically.
Excellent. I think people are starting to drop off the call, but I'll just open it up. You've addressed everything in the chat, Stefan. I'll just open it up as a last call for any questions for those of you who remain. Unmute, going once, going twice. Okay, I think we'll call it at this point. Thank you on behalf of everybody. Thank you very much, Stefan. Great introduction to all that's going on with SysML v2 and SysON, and it's nice to see your demo. It certainly was an eye-opener, and it looks like times are changing. Thank you very much.
Well, thank you very, very much for having me. And if you are interested in getting up to date on what's going on with SysON, one very good way is to connect to the LinkedIn page, or I don't know actually what's the name, LinkedIn account, let's call it like that, the SysON LinkedIn account. So that's, or you can also register to our mailing list to get those updates.
Excellent. Okay.
All right.
Now.